Hello, I'm Pinson from Syrlinks, from France. I take the opportunity of the ESA 3 Weeks 2021 to share with you some background and our return on experience regarding the design of data transmitter in the context of new space and for nano CubeSat. In 2011, the first Syrlinks X-band transmitter, so-called EWC28, was designed. It has been integrated in the ProbaV Earth observation satellite for a need of high data rate downlink. In 2014, Syrlinks has designed an X-band transmitter which is more compact, reusing the same transmitting technology such as used for the ProbaV, but dedicated for the nano CubeSat. This transmitter, referenced as EWC27, has been elected for the GOMX-3 mission, another ESA mission with needs for data transmission. We are today releasing a new X-band transmitter, the Exynos, that integrates some advanced transmitting technology in order to achieve much higher data rate. In 2013, the team started to develop a new transmitter, the EWC27, that has been used for GOMX-3 ESA mission. The mission consisted in transmitting ADS-B data to the ground station. The data rate was also 100 megabits per second, so very similar to the ProbaV, but one of the key challenges was to integrate the technology within a CubeSat form factor. To increase the transmitted data rate, the DBS2 technology is implemented. This technology inherits from DVB, authorized high level of transmission channel efficiency, very close to the channel and theoretical limit. It is based on very robust encoding techniques and very flexible configuration for the transmitting parameters. Furthermore, DBS2 permits to dynamically change those parameters during the flight according to modes: higher VCM, variable coding and modulation, or ACM, which is adaptive. The table here highlights the DBS2 mode implemented on our new product, Exynos. Up to 270 megabits can be achieved using 8PSK modulation, which is much higher than with the previous product, the EWC27. I have here highlighted two possible modes that can be selected at different times during the orbit, during the flight. This slide illustrates a telemetry use case with fixed transmitter parameters, very similar to the case of ProbaV or GOMX-3. The mode code here, OQPSK, is robust in order to operate in worse transmission conditions. Bitrate can reach up to 100 megabits per second, with an example here of 9 gigabytes of data transferred over 12 minutes. Now, on this example, we illustrate the capability to change the mode code in flight, and depending on the transmission quality, we can swap from QPSK to 8PSK in order to increase the downlink data rate, which can reach 300 megabits per second. The total data volume transfer is here more than 15 gigabytes, which is much more than the previous use case with fixed parameter. So what is the future for telemetry in terms of coming next technology implementation? First of all, we will continue to implement the DBS2 technology, and more precisely the S2X mode code, which bring additional possibilities for the transmission parameters. We are also proposing the same kind of transmitter for upper frequency band, such as Ka band. Indeed, the Ka band authorized to multiply by 4 the downlink capacity compared with X band. We continue to study different FPGA processor solutions, following the same strategy to find the best trade-off between processing performance, implementation cost, and form factor as required to address the nano CubeSat market segment. And last but not least, we are still working on how to make the product more robust as required for deep space mission, so not only low Earth orbit mission. I would like to thank you for your attention and I look forward to meeting you at ESA Field Week.